Hi there, everyone. Welcome back to our week on matrices. Today we're talking about determinants. Now, normally the determinant of a matrix helps you with finding the inverse. But what we're going to focus on is how can I answer this common ACT question with using determinants? For example, they ask you to find the area of a triangle whose vertices are located at, and they give you 3 ordered pairs. In our example here, I've done the same thing. I've given you 3 ordered pairs. Not a lot of people know that a matrix will help you solve this question quick and simple. First thing you do is create the matrix, and then we'll take the determinant. Now the matrix, the first 2 columns are made up by your ordered pairs. So -2, 5, -4, 3, and then 3, 1. Now a determinant has to be a square matrix, which means the number of rows must match the number of columns. So I'm missing a column here. Easy enough. We're going to fill it with the number 1 all the way down. So we have our matrice, and now we're going to take the determinant. I'm going to fill in my 1s here. Go into your calculator and let's create the matrix. Second matrix, and we're going to go over to edit. If you've missed any of the videos about how to create a matrix and how to input it in your calculator, feel free to go back and view those videos as well. Let's input our numbers. -2, 5, 1. And then our next set, -4, -3, and there's that 1 again. And last but not least, 3, 1, 1. Double check your matrix before you quit out of there. We have everything correct, so we're going to go back to our matrix, second matrix, and this time scroll over to math. That very first option, DET, that stands for determinant. Go ahead and select that, and then second matrix, and you're going to select the matrix you just created. So we're going to take the determinant of matrix A, and we get 48. So the determinant is equal to 48. Now, that didn't answer the question. The question said find the area. All we have to do is take 1/2 times the determinant, and you have the area of a triangle. So 1/2 times the determinant, which is 48. Now, if you notice down here, I have absolute value bars around my number. And that's because your determinant could be a positive or it could be a negative number. An area can never be negative. So we're going to make sure that we take 1/2, so let's do 0.5, times the absolute value of 48. Now, in case you're wondering, absolute value, press math. And at the top here, you're going to scroll over to number, and we're going to select that first option. And there's your absolute value bars. So 1/2 absolute value of 48, and we get 24. So the area of this triangle is 24. Simple enough, just using determinants. Let's try another question. Same setup, okay? This time we just have different vertices. Remember, when you make the matrix, you're going to put in a column of 1s because you have to have that 3 by 3 matrix. We're going to go back into our calculator. This time we're going to set up another matrix. We're going to make this matrix B this time. And we want another 3 by 3. All right, we have a column of 1s. We're going to have -2, -3, and then a 1, 3, 2, another 1, and then -1, -8, and then a 1. And again, always a good idea to just kind of check your matrix to make sure it looks correct. Now we're going to go back into our matrix operations and go to math, and we're going to select determinant. And this time we're going to take the determinant of matrix B, because that was the one we just created. Okay, so the determinant of matrix B, and we get -30. All right, so I'm going to fix this down here. I said matrix A, but we're actually using matrix B this time. So we're going to take 1/2 times the absolute value of -30. And I know you all can do that probably in your head, but let's just practice using the absolute value bars in our calculator. So we're going to do 1/2, and then we want the absolute value. So again, math, Scroll over to number at the top, and we're going to select the ABS. There we go, and we've got negative 30. Oops. Negative 30, and we get positive 15. So the area of the triangle whose vertices are located at those 3 ordered pairs has an area of 15. Check back in tomorrow to see how you can use determinants to find inverses. Bye.